So, next is multiplying vector by a scalar. So, a scalar again is a physical quantity that does not have, it's just magnitude or it's just a number. Okay? So, when you multiply a scalar to a vector, it's actually very simple. You just multiply it. So, if for example, you're multiplying acceleration, so you multiply acceleration. Acceleration is a vector. So we will learn it soon. That's our next lesson. And then you multiply it with mass, which is also a scale. It's just a scalar. So this one is the equation for force. Okay, force is equal to mass times acceleration. So you just multiply it. There is no any special way to do it. Okay, so that's for multiplying a vector by a scalar. Now let's look at the components of vectors. Okay, so what are the components of what do we mean by components? Ano yan? Parang big word. Okay? So, it's quite intimidating now, but yes, this is where we will be using what we call the SOHCAHTOA. Alright? So, this is where trigonometry will matter. Okay? So, components of vectors look at the reality of triangles. Okay? So when we say triangles, so we have your okay. So if you have a vector, let's say vector A, and it goes to this direction. Okay? Vector A may have two components. Okay? So vector A. How do you get from this point to this point? Okay? So you move to the left or to the right. Okay, and then you move up, right? So now this is your vector A sub x, or the x component of the vector, and this is now your A sub y, or the y component of your vector. Okay, so that's your vector component. So if you notice, vector A could actually have an angle there. And then, AX and AY is forming a right triangle. So, here now comes your trigonometric identities. Okay? So, yeah, trigonometric identities. So, ano ba yung trigonometric identities natin? SOHCAHTOA, SOHCAHTOA. Okay, but we will be using most of the time, we will be using the SOHCA only, not the TOA. Okay? So, how do we do this? Sine of an angle, theta, is equal to opposite over hypotenuse. Correct? Ka is basically cosine of an angle is equal to adjacent over hypotenuse. Right? And then TOA tells us that the tangent of an angle is equal to the opposite over adjacent. Now let's go back to our triangle. Let's go back to this. Okay. If you will notice, the angle have different. If this one is our angle theta. Okay, it has a certain relationship. AY has a relationship with angle A. So the cosine of angle the cosine of angle theta is equal to A sub x over vector A. Right? Therefore, we can say that the AX component or the x component of the vector is equal to A cosine theta. Next is, let's look at sine. So the sine theta of this angle is equal to the opposite. So the opposite of the angle is A sub y over A. Therefore, the y component of your vector is equal to A sine theta. Okay? So now, you're getting your component of vectors, the components of the vector. That's basically, oops, aray, joke. Stop. Okay, done.